We are very close to wrapping up Unit 2. Today we are talking about histograms, frequency polygons, and ogives. Same objectives that we've been working on, but we are continuing with our study. The students will be able to construct frequency histograms, frequency polygons, and relative frequency histograms and ogives. Review of frequency distributions. Here is our data set, and we need to create a frequency distribution. This is review. In order to do this, we need to locate our highest value, 450, and our lowest value, 59. We need to calculate the range, high minus low, which is 391. To get our class width, we divide our range by our number of classes. The information said the following sample data lists the prices in dollars of 30 portable global positioning systems, GPS navigators. Construct a group frequency distribution for the data using 7 classes. We start our frequency distribution with our lowest data value. We will add the class width to it to get the next lower class limit. Go back one from there to get the upper class limit for that first class. And now we're going to continue adding our class width to all our lower class limits. So we're going to add 57, add 57, add 57, add 57, and add 57. And now we need to find our upper class limits. So we're going to go back one from 173. We're going to go back one from 230. Go back one from 287. Go back one from 344. Same thing for 401. And to get the highest class limit, we're going to add one less than the class width, or 56. Class boundaries. We are going to go down a half from 59 and up a half from 115. Remember, this is 58.5 up to, but not including 115.5. We'll actually begin with the 115.5 on the next class. That is one less than the 116. We are going to end the class boundary for that class by adding 0.5 to 172. Remember, that is 115.5 up to, but not including 172.5. The next class, lower class boundary, begins with 172.5, and we continue that process to get all of our class boundaries. Sort out our data so we can find the frequency in each class. So we will count the number of data values between 59 and 115, and that was 5. Count the values, data values between 116 and 172, we got 8. Count the data values between 173 and 229, there are 6 data values. Count the data values between 230 and 286. Same thing for the next class, and the last class, and we always need to get a total, 30. And if we go back to our situation, it does say it is from a sample of 30 portable global positioning systems. And these are the prices. Cumulative frequency. By the end of the first class, we've hit 5 data values. By the end of the next class, we add in the 8 to get 13. By the end of the next class, we're adding in our 6 to get 19. And then we add in our 5, our 2, our 3, and our 1. To get midpoint, we are finding the average or middle value in each class. Add up your class limits and divide by 2. So 59 plus 115, get that sum, divide by 2, you get 87. We can calculate the next one the same way, or from one midpoint to the next midpoint is a class width. So we can continue adding 57, our class width, to each value to get the midpoint of each class. And you can always double check. For the bottom one, add 104 and 457 together, divide by 2, you get 429. To get relative frequencies, we take our frequency for each class and divide by the total frequency. 5 divided by 30, 0.17. Round to 2 decimal places, please. 8 divided by 30, 6 divided by 30, 5 divided by 30, we've already done that one. 2 divided by 30, 3 divided by 30, and 1 divided by 30. The total of our relative frequencies should equal 1. Due to rounding, we get 1.01. Because that total is not exactly 1, we are going to use our cumulative frequencies to get our cumulative relative frequencies in the same manner that we used to get our cumulative frequencies. We're going to move that one over to get cumulative frequencies, but we are calculating with these. So on the first one, 5 divided by 30, of course, is 0.17, but we take our cumulative frequency of 13 and divide by 30, 19 divide by 30, 24 divide by 30, 26 divide by 30, 29 divide by 30, and when you do 30 divided by 30, you end up getting exactly to 1. Graphs of frequency distribution. The purpose of graphs in statistics is to convey the data to the viewer in pictorial form. It is easier for most people to comprehend the meaning of data presented graphically than data presented numerically or in tables or frequency distributions. Statistical graphs can be used to describe the data set or analyze it. Histogram is the first one. The frequency histogram is a bar graph that represents the frequencies, so it is quantitative data. It's the frequency distribution of a data set. The histogram has the following properties. The horizontal scale is quantitative and measures the data values. The vertical scale measures the frequencies of the classes. Consecutive bars must touch, and that's where we use our class boundaries. Steps for making a histogram. We're going to draw and label our axes. If you are making them by hand, I will have that made for you. Represent the frequencies on the y-axis and label that with frequency. To scale our x-axis, we're going to use class boundaries. But when we label that axis, we need to do it in context to the situation. We're going to draw vertical bars for each class, and don't forget a title. Here is that same prices of GPS navigators information. We have our class limits and our boundaries and our frequencies. Our title will have frequencies on our y-axis, and the prices go on the horizontal axis, the x-axis. Our highest frequency is 8, so I did a scale. You have to start at 0 and go consistently up. And then our class boundaries go along the bottom with our lowest lower class boundary first, and then all of our upper class boundaries. The frequency for the first class is 5, so we'll draw a bar to 5. The next class is 8, then 6, 5, 2, 3, and 1. And there's your histogram. Relative frequency histogram is very similar, but we're using relative frequencies instead of frequencies. Horizontal axis is quantitative. It measures data values. We're once again using our boundaries. Vertical scale measures relative frequencies, so it's going to be decimals, and consecutive bars must still. Same data, but now we need our relative frequency. So our labels for our graph are very similar, except our y-axis is relative frequency, which means we need to calculate those. The total for our frequencies is 30, and we actually already calculated this on a previous scale. So 5 divided by 30, 8 divided by 30, 6 divided by 30, 5 divided by 30, 2 divided by 30, 3 divided by 30, and 1 divided by 30. So we need a scale on our y-axis. It's going to start at 0, go up consistently, jumping by the same amount, and get up to our highest value, which is 0.27. So I went up by 0.03s. So I added that same amount every single time, and we just happened to get to 0.27. Now, all the values that we need to calculate or present on our graph aren't exactly on the scale. There are 0.03 between each value, so we're going to need to do some estimating. Our first bar's 0.17 is right below the 0.18. 0.27, 0.2, which is going to be a little bit below the 0.21. 0.17, same as the other one. 0.07 is going to be just above 0.06. And then we have our 0.10, which is just above the 0.09. And then we have our 0.03. And there is our relative frequency histogram. Frequency polygons, a graph that displays the data by using lines that connect points plotted for the frequencies at the midpoints of the classes. Very important. It's the midpoints. Frequencies are represented by the heights of the points. Frequency polygon emphasizes the continuous change in frequencies. Here's our steps. We need the midpoints for each class. We are going to use that to scale our x-axis, but when we label our x-axis, we need to use the context of the situation. We're going to be plotting ordered pairs. The midpoint for our x value, or our horizontal axis, and frequency, which is the y value, our vertical axis. Scale the x-axis using midpoints and label your y-axis for frequencies. We are going to connect adjacent points with straight lines, and we need to finish it off, and I'll explain that in just a minute. And don't forget a graph. So here's our data. This time we need to calculate our midpoints. We already did that on a previous slide. There are our labels again and our frequencies. We've used those in the past. But we need to find our midpoints to scale our horizontal axis. So here are all the midpoints that we got in a previous slide. We add up the class limits and divide by 2. But in order to finish it off, we need it to tie down to the x-axis, kind of zero that out. So we need to go back a class limit on our lower midpoint. So if we subtract 57, we're at 30. And we have to do the same thing with our highest midpoint. We need to add the class width, and we get 486. We're going to use that to scale our x-axis, the prices for the GPS. We're going to plot each of these points, which we are going to get using these right here, because it is going to be the frequency and the midpoint. 30, we are going to start at 0 because we went back for that. 87, go up to 5. 144 is at 8. Continue plotting your frequencies for each of those midpoints, and then tie it down, and then draw consecutive lines between points. And there is your frequency polygon. An ogive is a graph that represents the cumulative frequencies of each class at its upper class boundary. To make it, we need to find our cumulative frequencies. We need to draw our axes. Of course, label your x-axis in context, but we're going to scale it using our class boundaries. Label the y-axis cumulative frequencies. So we're going to plot the cumulative frequencies at each upper class boundary. Connect adjacent points with a straight line. Extend back the graph to the first lower class boundary. So it will start at the lowest lower class boundary at 0 for our y-axis. Don't forget your title. So here's that same information we've been using. We need cumulative frequency. Bring over, well, there's our labels. Bring over our first frequency. There are the boundaries. Total is 30. Bring over your 5, add in your 8, your 6, your 5, your 2, your 3, your 1, and that total should be the same as the total of our frequency. So we are using those cumulative frequencies. Excuse me. So we need to find a scale on our y-axis that'll go up to the highest value, which is 30. Here is the scale that works. We start at 0. Make sure you always start at 0. And if we go up by 3s, we can get to our highest point of 30. We will start at the lowest lower class boundary with 0. And then at the 115.5, see the upper class boundaries, that list right there? In our table, we're going to plot it at 5. We're using cumulative frequencies. For the 172.5, we're up to 13. When we get to 229.5, we're up to 19. When we get to 286.5, we're at 24. When we get to the upper class boundary of 342.5, we've accumulated 26 values. Do the last one, and then we should get to 30 by the end of our highest upper class boundary. Connect your points. This is not a frequency polygon. We do not tie it down on the right-hand side. It should keep increasing until we get to our total frequency. Interpreting horizontal or histograms, excuse me. So we're looking at that graph. How many vehicles had selling prices between $24,000 and $27,000? Notice our x-axis scale is selling price in thousands. So look for that range, 18 vehicles. And with the scale, you would have to estimate, but above all the bars, it actually gives you your values. Which selling price range was most frequent? So the highest frequencies, 23. That's between 18,000 and 21,000. And how many vehicles sold for more than $27,000? So we need to add or total up the frequencies for those top 3 classes, because those would be more than 27,000. We are interpreting another histogram. It is showing the marks or scores on a Math 10 test, and it shows the number of students that received scores in those classes. So how many students had Math 10 test scores between 80 and 90? So look for the bar between 80 and 90, and there were 5 students. Which 10-point range of scores did more students have in comparison to any other 10-point range of scores? So we're looking for the highest bar, and that is between 60 and 70. So more students had scores between 60 and 70. How many students scored above 70 on the math test? So we are looking to add the frequencies for the class 70 to 80, the class 80 to 90, and the class 90 to 100. And when we total those up, there were 15 students that scored over 70 on the math test. We are analyzing or interpreting frequency polygons. The title, minutes practicing per day. We have x-axis contextual information of minutes practicing, and our y-axis is the number of days in which that happened. So 115-minute practicing times occurred on how many days? And about 4 days had practice times of 115 minutes. Which amount of practice time occurred most frequently? So our highest point is above 105. So the most frequent practice length was 105 minutes. How many days was the amount of practice time? 75 minutes or less. So we look for 75 minutes and we find that frequency. We find the frequency for 65. And of course, the frequency for 55 is 0, so we don't need to add that in. So only 7 days had practice times 75 minutes or less. We are interpreting another frequency polygon. It's the heights of professional basketball players. The height in inches is on our x-axis, and the number of players or frequency is on our y-axis. So how many professional basketball players are 84 inches tall? So we look that up, and there are 20 basketball players that are 84 inches tall. Which height is the most frequent? So we're looking for our highest point, and that's above 78. So the most frequent height for professional basketball players is 78 inches tall. We are interpreting Ogives. It's the weights in pounds of male gorillas. Remember, Ogives are cumulative frequency distributions. So our y-axis is cumulative frequencies. The lowest 15 weights for male gorillas in the study are below how many pounds? So we're looking for a cumulative frequency of 15. And then we're going to go over to the weight that corresponds to that. And the lowest 15 male gorilla weights is below 385.5 pounds. How many male gorillas are in the study? So we need to look at our cumulative frequencies and see how high it goes. So there are 50 male gorillas in this study. Your assignment for today is a quizzes assignment. It's already been signed in Google Classroom. It's on histograms, frequency, polygons, and ogives. You do have 3 attempts to improve your score. Please have this completed by Friday.